just in case you have problems of seeing the files and stuff, you probably need to first sign into the Google's cloud services if you have not yet done so. So there's the wiki metropolia.fi IT service. So IT services wiki. You remember Mikko Mäkelä from the first day you arrived to Metropolia. A help desk guy gave you some instructions where to find help. So that's the IT services wiki pages for all IT related questions. Yeah, and we are using the G Suite for education, but in order to use it, you need to first give a blood sample to Google and and a little finger, and how does promise to obey all the Google rules and regulations. And yeah. Anyhow, so we went through this signals part, that's kind of theory of the practice. And next we will go through some things about the exercises. So under all of these sections, I have the template for the exercise, and when you have logged into your Google account, you can open it and make a copy to yourself. Did you get that one open? Okay, good. If not, you are not logged into your browser with your Google account. Okay. Few ground rules. You can work with pairs. Actually, I recommend you not to work alone. This can be actually hard to work if you are alone. They are quite simple exercises, but sometimes you just get stuck, and asking the right question to anyone could help you figure out what I'm actually asking there. Don't go so far yet. I will show you. So, exercise, work on, basically, you may both work on the same. It would be a nice idea to actually have just one file on Google Drive and share it with your pal or group, max 3 students in one group. Share it, meaning, okay, first make a copy to your own folder, your favorite folder. Okay, that's fine. And after that, you do a couple of sharing things. Copy of exercise. You write your names. If more than one, just add some stuff. Share. There you put your pal's Gmail. I mean the Metropolia account Gmail. Okay. Or actually you can also put anyone here, since after it's yours, then you can share it however you want to. But it would be nice to have a edit share with your pal. Let's see. Let's see. Let me. I will share it with Kimmo Sauren. That's my friend. He doesn't mind. It would be nice also to have some notes there, but anyways, make sure that when you are sharing anything with anyone you want to who can edit, then you click can edit. There you go. Now Kimmo thinks, what? Okay. Then for return, you need to return only one of these, meaning not a file. This is in Google services. It's in cloud, magic cloud, and there, which means that you will share it using links. Get shareable link. Click. This is pretty nice already. Anyone at Metropolia Ammattikorkeakoulu with the link can, okay, I can give you feedback only if you allow me to. So if you click, anyone at Metropolia Ammattikorkeakoulu with the link can comment, then all the sharing is done. So share it with your working group to edit, and share it with anyone on Metropolia so that can comment. Done. We'll use the link later. There's a line. How many of you read the first line here? Usually that's the beginning of the text. You just, you don't need to read that one. Read the instructions first. So please read the instruction. Let's go through those just quickly here. Some general instructions. These DSP exercises can be done either with Matlab, which is installed on these computers, or Octave, what you can actually download to your own computer if you want to work on your own time. Matlab is actually licensed product, and we do not have campus license, meaning we have only on-campus license, not off-campus license. Okay. So, but if you want to make an investment, then it's, I think, something like 80 euro or something like that, the student version. But Octave actually works as well. I will be using Octave because, well, I don't want to put the Matlab on this small computer. Okay. Some things, most important, like parts, how to customize this exercise. Every one of you have exactly the same exercise. I want to see different results, otherwise it gets a bit boring. It means that you at least need to do the calculations with your own secret identity code SSS. Which is last non-zero digits of your student ID. When you are working on a group, use one of your student IDs for all the exercises. That's why I had this. Oops, where is that one? That's why I had this space for SSS here. Good. Okay. Working instructions basically are quite self-descriptive here. Start the Matlab. In my case, I'm starting the Octave. They look a bit different depending on which program you use. The Matlab looks more professional because it's a commercial commercial product and developed in 1982 already and have been growing since then. And this is the industry standard. Octave is again one of those GNU projects with, well, free but no guarantee. But I have tested everything works also there. They are quite similar. Let's put it this way. So commands on the this core level are exactly the same. They understand the same M files, for example. Okay. Log into Google account. Metropolia students should use the organizational account. Okay, if you don't have, there was instructions how to do it. Okay, one small thing. If you are really paranoid about giving any information to Google because it's part of the evil empire, okay, I kind of respect that one. If you find another way of returning the exercises, please do so. It might be a good idea to check with me if it works or not, but there are also some other services, like the Microsoft services that's not evil. Yeah. Cloud services like Dropbox. There are even, some of these torrent networks. There are different networks you can put those documents. You can use OpenOffice if you want to. This template can be downloaded with, I think it's ODT files, you can download it. And then you can work on it. Then you can put on some another cloud service than any of the evil empire. And then you must provide the link to the document. That's the important part. Okay, editable copy, I already showed. Change the document name. Wow. So, after copying, this is not a good name. How come? Maybe it's a good name to put it exercise 1 and then, for example, your team members' login names or something like that. That's my real email address is AntiKP, or real identity here. Change the name, just simple housekeeping of your own files. Names, remember to add the names here. Otherwise, I'll give these points to name 1 and name 2. Every year, name 1 and name 2 passes the course. Yeah, with FTSSS. Okay. And then answer the question, the reserved spaces. Okay, which are the yellow boxes on the right? So there's a column for each answer, and there's also a hint what kind of answer I would like to get. For example, there's the 0 point is the how to generate a produce vector of ones, meaning a table which consists only number ones. And same ways, basically, to working instructions. If you work on this Matlab or Octave, and when you have something working done, then you just copy and paste it here. Commands. I want to see the commands. Except in here, I want to see the figure. Okay? Are you all familiar with the Google Docs? More or less? Okay, it's very simple to add these graphs to the documents. Okay, so insert required graphs. Links. Okay, so if you have for example, voice sample, and I would like to hear your voice sample there, you will first generate it, put it into your favorite cloud service, add a link to this one, so that basically after that I can hear your sound sample by just clicking it, taking the link. As you can see, what I'm doing here, I'm trying to make this one as simple as possible for myself, for obvious reasons. I'm lazy. Yeah. Or actually, I don't have a robot to take a look at these results. I'm actually checking those myself. And then, of course, save the document. With Google Docs, it auto saves everything. So, publishing. Publish. Actually, the publishing means exactly this one. There's already now wait a minute, I'm taking another one here. On the exercise template sheet, right. So sharing, anyone with the Metropolis Ammattikorkealla with the link can comment, then you click copy link. copy link. Then test the link. My favorite way of testing. Incognito window. Paste the link there. Ha! I got it on the. Oops. Sorry. That one. It seems to work. So test your link with a incognito window to see that everything works there. Otherwise, it might be that I cannot comment or I cannot open it even. So works. So that was the publishing part. You just need to provide me the link. Test your documented. Yeah, easiest. Yeah, that's the. Next. Okay. Yeah. Submitting the link, meaning you are using the submission form. Okay. Submission form is right here below the template. Click. Wait a minute. I tested this one already. Why it's not showing it? Is Elomaki actually broken for? Oh great, Elomaki is not working. We'll have to wait until it's back online. Yeah, it's the first day at school, you know. I came to school around 9:30 or so. Oma did not open. Oh great, go back to bed. Yeah, hey, now it works. Good. So names, email address. Okay, this is not compulsory, but just in case, sometimes the something is lost, so to speak. This one helps me to send you an email that, okay, your submission did not work. For example, link was not opening at all. Exercise number and then URL like that and submit. What? What the heck? Why doesn't? Oh no. It seems to be somehow still under construction. Sorry about that one. I will fix it today. Tallenna or esitä the URL. Okay. Yeah. It seems that is not gathering information yet. But this is the official tool we need to use. We cannot use the Google Forms anymore for this kind of stuff. GDPR. Well, politics. The Metropolia policy. I don't make the rules. I just follow it. Yes, sir. Yes, ma'am. Well, if it doesn't work tonight, I will screw the rules and put back the form. But anyways, there are those 4 questions: name, email address, then the exercise, and then the link to the exercise. Yes, only one per group, as long as all the names are on the top. Then about the feedback. I can give you feedback only if you allow me to. So when you are sharing, it's important to then put that anyone with the Metropolia blah, 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 can comment. Otherwise, you will just puzzle, how come I did not get all the points? I deserve them. Then I'll reply to your email. You lost a point because you didn't add the comment. Right. Okay. And by the way, if you want to improve an acceptable return, you do it yourself. I do not fix the grade anymore. That's done, and I'm actually relaying and now on the degree regulations. That's an excuse for me. Excellent excuse. And that one, wait a minute. Okay, that I need to discuss with Janne about this one. Is it the total points that matter, or do we have a minimum point? Mini points, yeah. Okay, we will follow the minimum points total on this section. The same rules as the other ones. I'm not changing this one, but anyways, now you know it. Okay. Unless otherwise. Unless said otherwise. Yep. See how easy it is. I can change the rules when I go. Yeah. If you don't hear anything about it, it means that everything was correct. I didn't get anything, any delinks or any returns from you, or then most possible is that actually I'm busy with something. I have 4 implementations on this period, so it might take for a while me to go into the go all of these exercises. So don't ask the results on the same hour when you return it. Maybe the next one, but not the same hour. This is then ugly, I have to just tell you. Copying parts from some others' return. You are here to learn, right? This is a skill that you quite probably will need it at some point of your working career. Okay, learn it well. I just give you tools to learn. So if you just copy, I think you already know how to copy and paste, right? And yeah, link sharing. Okay, I have a picture of link sharing here, but actually that was anyone at the Metropolia Ammattikorkeakoulu with the link can comment would be a proper. If you want to share it with the rest of the world, it's up to you. This example is for everyone. Okay, any questions for the general instructions? No? Nope. Back to the exercise, and so how this one actually works out. So how many of you have used Matlab at some point? Any course, I think mathematics, you have had few exercises. Some are nodding, some not. Okay, as I said, I'm using actually this Octave package, which is GNU licensed product similar to Matlab. Can you see the font? Is it big enough for the back row? You guys see it well. Good. If you don't, I can increase the font, or you should also take a eye exam. Seriously, it's supposed to be big enough. All right. So that's more or less how the also Matlab window would look like. There is a command window. I like to work on the command window. There's also editor window. Some people actually prefer working on the editor. It does not make any difference how you do it. I use command with, so if you use the editor window, then you write the commands here and then you execute those line by line or section by section. Okay, but Basically, this exercise templates are done so that in a kind of sense that it's easy to do one by one exercise and then copy paste stuff. Okay. After this class, I will also upload the history file. There are already last 2 years history files here. They look like that, just command M files. So yeah, well, let me just copy paste that one to see how it works. So basically, last year I created a index vector just for fun, like that. N equals to -2, -1, and so on. This is one way of creating vectors. Vector is nothing more than a table of values. I call them vectors because, well, digital signal processing we call, n by 1 or 1 by n matrices as vectors of tables. Single tabulated data. There, that was simple. This can be now used, for example, for sampling. Let me draw a little bit here. So this could be just the axis information from -2 to 5. So sampling points or sampling indexes, table indexes. Don't worry about the negative table index. Well, if there is a table actually defined like that. You have had C programming language classes, right? Remember pointers. With the pointers you can make dirty tricks. So if this was a, how many points we have? A table of X, 8 values in C, then you could have this N as the pointer to, let's see, the address of X 0, 1, 2. Okay, then there you have the N index. Okay. So this is just a mathematical dirty trick how to use the pointers to make the offsets on the table. Okay, this would be some sort of regional interest. And then we have this on the theory part. We have this, for example, impulse function. Impulse function. By the way, if you didn't guess it, the present sign actually starts a comment section. So the end to the line end, actually it will be the comment. So you can document your stuff while you are going. So impulse function was defined that it actually gives you value 1 at this point, at index n. So that n was from -2 to +5. It's 1 here, 0 otherwise. The Matlab command to produce that one basically shows also the what is the beauty of this nice tool what we have. Impulse function. That's a bad name. Well, I'll just let it be like this. When you are naming the variables, you might actually first check if there's a variable or function exactly the same name, since you can very easily here also destroy these commands which are inside of the system already. So I would say delta function or DD or delta or something like that will be better name. So whatever you set here as a variable, the variable name will be actually the first one that this system looks for. So you can destroy, or not really destroy, but overwrite any system command. Just like I or J, the complex unit, actually you can kind of, then you get weird results. Okay, but anyways, DD equals, we make a test if that n equals to 0. So this actually returns true on the place where the index goes to 0. And from the C programming language, you should remember that only the false has exact value. False is 0 and true is anything else on C language. So the safest way of making sure that this is actually numeric would be saying double. So we do casting to double numbers. And there we have double, then the logical test NN equals to 0. Same way as in C language, actually the single equal sign is setting a value to a variable, and double equal sign is the testing for equality. Okay. Now we have the data, which can be seen on the Workspace Explorer, but this is kind of cumbersome. One way actually to look at these values is to draw graphs, and this would be the stem plot. Was it? Now I don't remember. Was it here on the Octa? We'll see. Help stem. Yes, there's stem function. That's great. Good. And different uses. On Matlab, you will have really nice the help on each of the functions. Take a look, for example, doc, right there, doc stem. It opens a help explorer. You can find all sorts of stuff and usages and examples and stuff like that. The content is similar to this one, which looks nicer. Okay, so stem XY or stem XY. I think we will use the stem and NN and DD. Yeah, that's how impulse function looks like as a stem plot. This is a typical way of showing of discrete time data of few samples. If you have more than 100, then you would probably use some sort of scatter plot or just line plot. But this actually shows quite nicely that, okay, it looks like, yeah, it looks like exactly like that, but you need the binoculars to see anything from that one. Anyways, let's think that this actually is a picture I would like to add into my document. I think I can do it, was it like that? Save as bitmap image formats. Whoops. GIF. Oh, yeah. Yeah. Does it go there? Yeah. So now it's GIF. Maybe. Untitled.gif. We could have had the name for that one, but anyways, let me go into browser now. Documents. Where did I hide that one. I hid that file. Okay, that file is actually located in the current directory. You can change the current directory quite obvious ways. But I have it here. It looks like a GIF file. Yeah, looks quite similar. If I want this one to be on my document here. Where's the other? Okay, insert the figure here. Okay. Let's see what happens if I put it just here. Wow, magic. Oh boy, it was so hard. Same way as you add any figure on any doc. You just drag and drop. And this is the a network document. Remember the limitations of network documents. Not all the file types are actually okay. But on that figure, the save as actually bitmap image formats. That'll be just fine. Bitmaps are usually used on the web pages and such kind of things. Octave figure file, actually, that goes well with the GNU license products. I think the OpenOffice can directly use the Octave files. Vector image formats, well, if you have some real editing program, then you might actually want to use those. But bitmap vector, that's fine. Okay, then back to this one. Stem. So this is how you create an impulse file. How about then how to create the step file, step function, Heaviside, or sampled Heaviside. Oops. What happens? Not responsive. Yeah, no, it's not. Yep. Same way. Except now the test is nn is greater than equal to 0. Semicolon at the end actually means that it does not show the result. That's handy if you have, say, hundreds of data points, then you really don't want to see the result. It's just saved on the saved in here. And then we can, of course, stem that one in UU. Yeah, boring. On the exercise, there's also the time delay. If you want to generate, for example, the delta function at position n minus 1, so it's 1 time step delay. That actually corresponds to, well, let's start from here. Simply do it like that. This is the safe way. So it's basically the delta with the input parameter here is nn minus 1. 1 time step delay. Safe way of doing it. Yeah. Yes. But with the time advance, you get easily mixed which one was minus or plus was delay and which one was the yeah. But yes, yeah, same thing. And time delay means that this event will happen on later time. Not -1 plus, but plus 1. time step. Okay, that was the all the magic behind these basic sequences. Now the sampled sequences, like sinusoid. Few ways of generating it. But before that one, let's do the auto generation also. Same as we had this one here, -2, -1, and so on. This, if you have 255 points here, it's kind of takes time, and you make a couple of mistakes at the middle, then the data is all destroyed. Okay, how to auto-generate this sequence is you'll put -1 colon operation and up to 5. So if you have single colon operator here, it means from this point with a time step of 1, or well, the step of 1 until the last. You can actually start from 0.5, colon 5 would generate you 0.5, 1.5, up to 4.5. Okay, this is one way of generating, which is equal to basically this one. So from -2 with the step of 1 up to 5. Those are equal. So from step 2. Okay. So next we can go to the sample stuff. So sampling theorem says that x of n, n equals x of n times the sampling time t. I have no idea now about the sample time, so I have to figure it out. So what would be a reasonable sampling rate for example, some accelerometer signal? Yep, that's good. Why? Just because. How fast do you think that the airbag should be deployed? Yeah. But yeah, 100 samples per second would be excellent for, say, human body movements. Perfect. How fast a human being can actually do drumming? I have no idea. Highest rate I think is somewhere around 40 hits per second. So 20 on each, and that takes some technique. Okay, 100 hertz. Yes, let's put that one. So example, sampling rate is 100 samples per second, meaning that, well, now we have a parameter, and then we have the sample time is simply 1 over fs. There we go. That wasn't hard, was it? Now we can use actually that n times t, and let's have some sort of sinusoidal movement. Okay. Yes, Guitar Hero. How many circles per second a Guitar Hero can do? Maybe 2 circles per second. That's a good frequency. 2 hertz, 2 revolutions per second. Signal frequency. So signal frequency, FF, equals to 2. This is the signal frequency. And then we have this signal could be then X, sampled signal, mean amplitude what is the G force here? Okay, 1G at that rate, roughly 1G, 0.5. Depends on the hero. Sine 2 times pi times signal frequency. So that's the 2 pi f. And now we have just need to add this sample times here. And sample times is this index n times ts. So wait a minute. Here we have the sinusoid. So here we should have the kind of sample points, and it should look like sampled sine, although, well, seeing is believing. I think we just have quite gradual change here. Since we have 100 samples per second, and we have only half second is the period time, and we have only 8 samples. So we don't see much of change here. NN XX. Yeah, so it looks like that. Sampled function. Basically, you just have the function as a function of, well, so let me add here the comment. So we have the amplitude 0.5 times sinusoid of 2 times pi times f times t. That's the function. The continuous time function. And we just sample it. Replace t by n times sample time. Simple. Good. This unit step function is actually a pretty good tool then to start a signal at some time. For example, if our signal is turned on at index of 0, if we want to look how the system actually reacts for a signal when we turn it on rapidly, is there any kind of this kind of bangs on the beginning or something like that? The response. So there we can actually then multiply the signals. Oh, so we basically have this cell-wise product. So we take product. There we go. XX2 equals to XX and then dot operation. Dot and combined with any other operator actually means that this operator is done for each element separately. So if you want to try to multiply just this x with u, you will get an error message. Matlab or Octave, they are vector calculators, or matrix calculators. They can easily, you can get answers to matrix products or vector products, but then you need to take care of that the dimensions are matching. In here, we want to multiply the signal, each value of the signal with this step function to turn on the signal at center time. So that's where we need this point operator. So next operator is applied to each element separately. So let's stem that one. Okay, and now we have a signal that turns on at time step 0. It doesn't start at the -2, but starts go on the time step 0. Okay. Now I need to take a look at this. Aha, good. This is fine for simple data sections generating, say, that kind of signals that start at some point, generating snaps or this kind of impulses into the as a test used as a test vector for the system. But just for fun and do something really applicable, let's try making a real sound sample. Like, okay, generating real sound samples. Real. Not really real. Okay. For that one, actually, we can use this kind of indexing methods as we did earlier. On the other hand, if we have a say question like, say, what is note A? Excellent. You are not playing oboe. Yeah, something in between. Whatever oboe gives you. Yeah. Note A is 440 hertz, and that's the the basic note A. Next, the first harmonic would be next octave, meaning 2 times that. Second harmonic 2 times the previous, and so on. Note A is 440 hertz, and then let's play a little game. So how many half notes there are on octave? Yes, 12 half notes. Yes. Let's make a chord then. A minor. The chord. Yeah, that will be with notes. A and C minor, right? E. Is that a note? A, C, yeah, and the middle one is minor. No, it's yeah, C, just C. Yes, good. ACE, that's like a vitamin, so drink. Right? Let's make a chord. This is kind of fun, but anyways, so those frequencies would be then let's link it. FA is 440 hertz. What would be then the C note frequency? Meaning how many half notes there are in between? No. There's one full note and then there's another. Yeah. Is it 3? 3 and 5. Yes. Yeah, but I want to have a formula here. 2 to the power of, right? If A, yeah, times 2 to power of means actually the this operator, hat operator, number and hat operator, and then we have how many half notes there were. Yeah, about 12 in total, but but between A and C, 3. Oops. Yeah, tilde. 3. So that's the whatever middle node that is, and then F frequency for E would be F8 times 2 to the power of is 5 or 6. You should know it. Hey, you started at the beginning. Your fault. 6. 6. Yeah. Yes. That will be weird. 12. Yes. Yeah. It must be like that. Yes. Okay. So these 3 notes would give you a perfect chord of A minor. Was it equal? No. Yes. A minor. Good. Now we just need to generate the frequencies with a certain sampling rate, like sampling rate equals to, well, let's make it CD quality. CD quality, 44.1 kilohertz. It dies hard. I know. Eventually it will die. Then we just generate the sinusoids. 3 sinusoids. Sinusoid 1. Amplitude, well, I will just put for fun amplitude 0.3 that I don't overload the sound blaster here. Sine 2 times pi times frequency for that one, and then I forgot to do the sample sorry. My fault. My bad. Let's make the sample times. So n times t to put into each of these sinusoids. One way would be to do it the sample time vector from 0 with the time step of 1 over fs. That's the sample time. Yeah. We have the sample frequency, so 1 over that one is the sample time, and then, for example, 1 second long sample time vector. There we go. Now we can generate those different notes. Now tones SA equals 0.3 times sine of 2 times pi times F8 times T. So this is N times T already. First signal, then for the C note, and then for the E note, and with some luck, this actually works. 3 different tones. So, for example, sound SA with FS. FS. Okay, this is how you play the sound. I have no idea if the audio here is connected or not. Maybe it is, maybe it's not. It's not connected on this computer or output device. Okay, one of these. Sound. No, it doesn't sound. Anyone? Where? Yeah. Thank you. That's really nice of you. Woo. Yeah, that was A. So this is C. And then we have the E. And then we can combine these to make the chord, which means that we have the A plus signal C plus signal E. Yeah. Isn't that beautiful? Yeah, that was overloading the some amplifiers there. Yeah. Okay. But anyways, the idea is like that. So make the sample time vector, then you can have any sinusoid there to sample. You can actually then put envelopes. You know how to do the sample different kind of functions. You can put envelopes like attack and decay. Anyone having an old-fashioned the synthesizer? Nobody. You have yes, attack, decay, right? So envelope for the sinusoid. If you have a attack, it means how hard it hits the beginning. Attack is actually this kind of exponential function. Decay is this kind of exponential function. So basically, combining these will give you, like piano kind of sound to that one. Do you believe me? No, you don't. Well, try it out. It actually is, with some modification, it sounds like electric piano. Okay. So practically, you can start producing your own music with that. Yeah, that'll be the first exercise. More 1 point out of that. No. The exercise itself actually includes producing 8 times the sampled sinusoid with some noise, white noise generator. On old-fashioned analog, the synthesizers, this was actually Johnson's noise in a amplified Johnson's noise. Simple, was it 100 mega ohm resistor on a bad operational amplifier. Then you amplify the current noise, and that's mostly Johnson's noise. Okay, how to add some artificial noise into this one? Noise is random variables or random numbers, meaning that we will add for each single element, we add something that we don't know of. A random variable between some or with some statistical properties. Okay, let me make this one as SS. SA plus SC plus SE. That's my signal without noise. How you measure signal to noise ratio? In decibels. Oh, yeah, exactly, I know. You need pen and paper now. Seriously, yeah, it's the 10 log 10 power of signal divided by power of noise. Signal to noise, yes. Signal to noise, yes. Power is actually directly proportional to variance. Repeat. Power of signal is directly proportional to variance of the signal. Yes. Remember the power of the any signal you have the square of something minus and yes, and then you integrate it over the and divide it by something. Same way here, we can calculate the variance of our signal, which I call power of signal, variance of SS. Then we have this random number generator that can give you either uniformly distributed random numbers or Gaussian distribution random numbers. Natural noise is usually Gaussian. So let's make the just random numbers. Noise, NO, equals to rand n. Rand n is normally distributed random numbers with 0 mean and variance of 1. Great. Random numbers, size of the signal sample. So generates a random number for each signal value. And we can check, okay, power of noise is variance of that noise. Yeah, close enough. Why it's not exactly 1? This is because of this is simulation, or actually we are measuring it. There's always some uncertainty when you are measuring things. But those random numbers are quite random, actually. Let's take a quick look at noise values. Yeah, there's absolutely nothing that repeats here. It must be then more or less random. Good. I will show you just the easy part, how to now measure the signal to noise ratio. Signal to noise ratio was 10 times log of 10 of power of signal divided by power of noise. On the exercise, though, you need to do it the other way around. There's a given signal to noise ratio, which depends on your secret number, and you need to find out how to scale your noise such you can get this required signal to noise ratio. Oops. Okay, that's minus 8 dB. Sounds like there's more noise than signal, right? Hearing is believing. Another actually practical command here is sound SC. It scales the values between 0 and -1 and 1. It helps a little bit. Then it doesn't overload the sound blaster. And we have the okay, signal with noise with sampling rate. Okay, there's this hissing sound, but you can still hear the chart behind of it. Right. Wow. Magic. Not quite. Okay, so that's how you generate some noise. And as I said, well, you are electrical engineers. You eat decibels in morning, so this is how you generate this. You need to have this given signal to noise ratio on your noise. It means that you need to rescale the noise part with some magic number, what you get by calculus. I give you one more hint, only one more hint for this one. Maybe I should give you on this one. So basically, you will actually need to rescale the noise with the required standard deviation. So square root of the required variance. Okay. So in order to achieve that certain level of, let's see, SNO, yeah. You have the SS, but then you rescale that noise part by multiplying by square root of the wanted variance of the noise. So you calculate the required variance of the noise, then you use that square root of that, meaning standard deviation, to scale that noise values. Something like that. This gives me some trouble. Syntax error, yes. Yeah, there are some hints. Okay. Then you need to actually save that sound sample, and there are, on Matlab, there's audio write command. Yes, and also here we have audio write. You can set the file name, data, sampling rate, and this actually, let's see, what is the audio format. You can there also add there the audio formats. Audio write. How was the title? File name. Test. And Snow FS. By default, it says gives me error. Oh, because I didn't have the SNO. Yeah, of course. SS. I have SS. Failed to open. Okay, read the more about the documents. In Matlab, it's actually pretty much easier than in this Octave, but you need to find the documentation and find how you can actually write these into the WAV files. WAV files. Let's see. Does it record? Okay, that works. It's just at the the endpoint that it recognizes which format you want it. Oh, that's nice. This is a nice thing about this open source software. You never know how they actually how smart the code writer was. This is pretty smart. Okay, and then provide link. Remember to upload this file to your favorite cloud. Don't leave this link to the local computer. It usually does not work that way. Otherwise, this is my show for today. Thank you for listening. You have been a great audience, the best this far this year. And welcome back next week. I have another class actually overlapping this one. It starts at 5 o'clock. So these sessions will be until 5 o'clock, meaning that today I need to leave a little bit earlier. If you have any questions, ask your pal there next to you. If cannot find the answer, then ask me. I will also answer the emails. When you send the emails, please put on the topic which course. So embedded electronics, DSP, and then the question. Okay, with the Manfred Juncker. Yes, that one. Yeah, it's okay. I need to talk with Janne about it, how to actually do it. So for me, it's sure. It's the theory part, and it's heavy theory. Yeah, it's goes pretty deep, and the calculations and it's the second best course ever. Yes, please do so. Yes, I'll take a look at what we can do about it. Yeah, if it was up to me, that's fine. But you never know about the Janne. Mm, mm. Yep. So theory is pretty much the same, but these exercises are different. Yeah. Yeah. Paper. Yes. Yeah. Except the slides, the overhead project. It's so much fun.